Hi, it's Steve again. Welcome to Particles Part 5. I really can't put it off any longer, so this video is looking at rendering. Particles are infinitely small points. They have no size and do not appear in the render views. Not very useful, you might think, in an application that's all about creating imagery. But panic not. There are several ways in which particles can be made visible. One option is to connect the particles into a volume item, such as the sprites in this segment, and remember the fireworks example from the previous video. Alternatively, you can use a volume to create clouds or fumes, and blobs are best suited to liquids. Another possibility is to use particles to position geometry using a replicator. Replicators have been in Modo for quite a while, but of course with the addition of the particle system they become even more useful. There are a couple of other ways to use particles in rendering, which I will reveal in a minute. Okay, if you must know, it's possible to convert a particle cache into geometry and to render that. And finally, texture replicators are also controlled via particles, so we can use particles to manipulate textures. Let's look at replicators first. Here I've got a replicator. A replicator needs a particle source and a prototype. There's two ways of connecting these up. We can either connect them up in the schematic, or we can select them from these drop-down menus here. I'll stick with the schematic for now. So first we need a particle source. I'm going to use a particle generator, and in this case I'm generating an array of 4x4x4 particles in a 1x1x1 meter grid. So we'll use that as our particle source, and we need a prototype. So let's connect in this cone, for example. And if I bring up the preview render, you can see that the cone has been instanced in this regular grid pattern. And obviously I can change the prototype and we get spheres instead of cones. Now something I didn't realize you could do was that you can actually connect in two prototypes. And what Modo will do is randomly choose between those prototypes. There's another way of achieving the same effect, and that is to connect a group as a prototype. And we get the same random selection. Now, Modo group is a term that's used an awful lot. This kind of group is the kind that you create from the Groups tab. Let's delete this group and recreate it. So if I select the sphere and the cone and then do New Group, call it Sphere and Cone, from selected items, OK, and now we've got the sphere and cone group, which I can put into the schematic. Right, that was an adventure with groups. What else can we do? Well, something that happened to me by accident when I was doing this was I connected the sphere as the particle source, and that works fine because the sphere has a number of vertices, and each of those vertices can be thought of as a particle. And the result's quite pleasing. We could reverse the roles. I'm not sure what it is, but it's quite fun. Okay, one last wrinkle is we can actually connect up a compound object as a prototype. And in this case we have to enable the objects and we get a replicated compound object. For that to work properly, you also have to make sure that you check include child items in the replicator. Otherwise, it doesn't work. Using the particle generator directly generates a very regular pattern. That's what it's meant to do after all. If we want to mix things up a bit, then we can use a particle random modifier. This will apply a random amount of position, rotation and scale to each of the particles. So let's wire that up. Now we can see our cones are now all randomly rotated. I could add a position, and now they're randomly rotated and randomly positioned. Next, let's look at the volume items. Volume items are peculiar because, in a sense, they don't really exist. To explain, mesh items are real because they correspond to polygons, edges and vertices. Volume items, on the other hand, have no geometry. They only exist in the process of rendering an image. They are figments of the renderer's imagination. Very useful figments, though. Sprites are the first volume item I'll look at. By default, a lone sprite just looks like a fuzzy blob. Sprites are essentially 2D objects. They have no volume, and whatever direction we look at them, they always have the same shape. Sprites are a bit like a sheet of translucent paper that's always facing towards the camera. We can replace the fuzzy blob with an image of our own selection. There's quite a few settings in the Sprites controls, so it's useful to expand up the controls area. This is a new feature for 7.01. Gives us a lot more room to play with. Can load in an image, and the preview doesn't really seem to update very eagerly unless you tickle it. Because sprites have no associated geometry, we cannot use the standard polygon tag method of attaching materials to them. That is, we can't use the M key and attach a material to a sprite. Instead, we have to create an item mask. Create item masks by right-clicking on the object and selecting Create Item Mask. Now, I've already done that for the sprite, so we'll see in the shader tree a sprite material, and the controls within the material that affect sprites you'll find under Material Rays section. We can adjust the scattering amount, which determines how much light is scattered back from the sprite. We can change the color of that scattering, and we can adjust the absorption amount, and the color of the absorption, and we can also make sprites luminous. The density controls the overall size and transparency of the sprite. Of course, the reason for looking at sprites at all is because they behave just like replicators. We can use particles to create instances of sprites. The next volume item is rather confusingly called a volume. Volumes are regions of smoke or vapor. Unlike sprites, they are true 3D objects. They can be shaped according to some default geometries, or an arbitrary closed surface can be used as a template. In my experience, volumes tend to be quite costly to render, especially if volumetric shadows are enabled. Let's see what a lone volume looks like. As you can see, this is a genuine 3D object. We can move around and see different aspects of it. Just like with sprites, in order to attach a material to a volume, you have to create an item mask. If you thought there were a lot of settings for sprites, then you're in for a bit of a shock when you look at volumes, because there's 2 tabs containing all the settings for volumes. Let's have a look at the volume particle settings. We can change the shape. This is a volume cube. Cylinder and sort of cloud shape, which is referred to as cumulus. We can also specify a surface to act as our template. And in order to pick up the material for that item, there has to be an item mask. I created an item mask for the cone so that we can pick up the material associated with that cone item. So just like with sprites, we can plug a particle generator into our volume item and replicate it. Blobs are the last volume items to look at. A single blob is not much to look at. But when blobs come together, they merge in interesting ways. A collection of blobs together can look similar to a liquid. Let's connect the particle generator into the blob. I now have a collection of blobs, and I'll show you how the colouring is achieved in a minute. The surface level is at 100%, then the blobs won't merge with one another at all, and the radius essentially is the radius of those blobs. If we adjust the surface level, then the blobs will be more inclined to stick to one another, but they'll also get smaller, so we have to increase the radius in order to get them touching again. And now you can see that the blobs are beginning to join together and merge. We can take this to an extreme. If we reduce the surface level right down to 0 and wind up the radius, there's a sort of critical level where interesting stuff starts happening. Okay, so I promised to show you how I got these colours. Well, as with volumes and sprites, blobs are controlled by an item mask. Let's go into the shader tree and have a look at the item mask for the blob. The colour of blobs is controlled by the diffuse color channel. And in this case I've taken the particle ID as the input parameter into this gradient, and the gradient is controlling the diffuse color. If I just disable the gradient, then all the blobs will be the same color, and I can edit the color and other properties such as the specular amount to make it more or less shiny. We could add some reflection. So we've got all the machinery in place. How do we put it into action? Well, in this model here, I have a surface particle generator, which is generating particles on this ground plane. As I scrub the timeline to and fro, you can see that the particles are expanding and contracting. How is that achieved? Well, the surface particle generator has an item mask associated with it, and that item mask is controlling the particle density. And I'm using this circular built-in texture to modulate the density of the particles so that everywhere where there's a circle we get particles, everywhere there isn't a circle there are no particles. I've also animated the spacing of the particles such that when they're near the center the density is much higher, and when they spread out the density is lower. So these particles are acting as sources for this source emitter, and again you can notice that I've animated the emission rate, the velocity and velocity spread of the particles so that at the beginning of time we have a very high emission rate and a high initial velocity, and at the end of time we have lower rates. Now normally a source emitter emits particles in all possible directions from its source particles, so I've added to this framework this yellow section, which is the straight up particle operator. This particle operator acts on new particles. It reads their velocity in the x, y and z direction, calculates their magnitude, so that works out the size of the vector. I take the y component of the vector and make it positive, that's so it's pointing upwards rather than upwards and downwards. And then I feed that into this set length function, which takes the length of the original vector and normalizes the y vector to be that length. That way I preserve the randomness of the velocity spread from the source emitter, but I've arranged for all the vectors to be pointing straight up in the y direction. And then we feed that resulting vector into the straight up particle operator, into the writable x, y and z components. Of course the x and z components are going to be 0, so I needn't have connected these up, but I might change my mind and decide that we want some other values coming in here. Okay, so that will cause the particles to be emitted straight up. Let's run that and see if it does what we expect. And I think that's more or less what I was expecting. So there's some gravity in the particle simulation. We're causing the particles to go back down towards the ground. We don't really want to be dealing with them once they've gone under the ground. So the only other feature of this rig is that there's a killer particle operator. This particle operator will act on each particle as it goes round the simulation loop, and I'll look at the Y position. If it's less than 0, then I kill it, because I'm like that. Right, so the particles get generated, go into the particle simulation, they're pointed straight up, and they're killed when they get to the ground. The point of this video is to look at rendering, so I'm taking the result of the particle simulation and feeding it into a replicator with a prototype, which is just a simple piece of geometry. Before I go and render anything, I thought it would be worth just showing you how I control the locator for the circular texture. It took a little bit of thinking about, or at least it did for me, because I'm a bear of little brain. In this auxiliary workspace, Texture Locator control, I've wired up the controls for the circular texture locator, and I've animated the value A channel on this add node just to get a constant value in. So it's animated from 0.1 up to 4.28 apparently, and that number is fed straight into the position of the locator. As you can see, the locator is moving in the XY plane, but it's also being scaled by a factor of 2 and applied to the scale of the texture as well, and that means that it expands out with time as well. If I were to remove the scale, then the texture would move, but it wouldn't get any bigger. Similarly, if I was to remove the position, then the texture would get bigger, but it wouldn't really do what I wanted to do, which would be to expand about a fixed point. So I compensate for the scale by moving the texture and then we get it expanding about a central point. Well, we're nearly ready to render. There's just one other thing. Oh no, not another thing. Yes, another thing. The eagle-eyed amongst you will have noticed that the particles being replicated were not at the same orientation as one another, and I showed you one way of achieving that. There's another way. In the variation section of the replicator, you can assign random offsets, twists and scales to the replicators, and this just sort of mixes them up a bit so that they don't all appear exactly the same. It's another way of achieving some randomness. So finally I'm going to do some rendering. Before we can render any particles, we need to bake the simulation, and we use this green button down here to achieve that. So we need to specify a start time and an end time, and we can also specify a pre-roll. What pre-roll does is it runs the simulation for a number of frames before it starts rendering. This lets your simulation get into a sort of sensible state if it needs to get going before you want to start filming it. In my case, I don't need to do that because the simulation starts off just fine. Okay, so we let the baking process begin, and I'll pause the video. I'm back again. We can now scrub through on the timeline to get an idea of the dynamics of the simulation that we've baked. Make sure that it's doing what we want it to do. Okay, so that looks fine to me. What I need to do now, before I actually do any rendering, is I need to turn the surface particle generator for the ground on. This is going to generate some texture on the surface. And the other thing I need to do is disable this emitter, because I don't want that in the final render. So now it's a good time to do a render of an individual frame, just to make sure that things are looking how we want them to look. I won't make you sit through this because it's going to take rather a long time, so I'll pause the video, and this is the final result. Once we're happy with a few test render frames, it's time to render the entire sequence. Do that with render animation, specify a start and a last frame. You can also specify a frame step if you want to skip frames, and we have options to save as image sequence, movie or layered images. I'll save as a movie. Pick somewhere sensible to save it. What shall I call it? Test. That's an imaginative name. And then save. Specify the quality of the and type of output. And then off we go. Now is the time to go to bed. And after a number of hours of rendering, this is the final movie. This model uses a number of features which I haven't explained yet in this video series, including the dynamic solver and dynamic collider. I'm afraid they're going to have to wait for another day. But for the purposes of rendering, we're simply connecting the particle simulation into a volume item, and so we're getting a cloudy volume at each of the particle positions. And if I scrub through the timeline, you can see how the particles are moving with time. When baking this model, I used the pre-roll in order to advance the simulation sufficiently far that we had particles throughout the scene. One thing to note about this animation is that I've created a size gradient for the particles, keyed on particle age. If we look at the graph in the graph editor, see that at time 0 the particles, or age 0, the particles have 100% size, and at age 480 they have 0% size. There are a number of other attributes of volumes that can be controlled in a similar way, such as the colour and the density. There's another way of making particles visible, and that's to convert them into geometry. Let me demonstrate how that works. Without the aid of a safety net, I'll create a simple particle system. Let's add a radial emitter, first thing we need to do is bake the simulation. Once the simulation is baked, we can convert it into geometry by selecting Dynamics, Convert Particle Cache, Particles to Curves. For that to work, you must make sure that the particle simulation is selected. And notice that the curves have been put into a mesh item that's been created, parented to the particle simulation. Because these curves are just pieces of geometry, we can render them in the normal way. If we select the mesh and then go into the curve settings and select Render Curves, the curves will now be rendered. And there are various options for rendering curves. We can adjust the radius, and we can choose to render them as polygons. If I reduce the number of sides, it'll become obvious that these things are now polygons rather than rounded tubes. Another option allows us to adjust the radius of the curves according to the distance along them. Okay, so we can begin to see how we can create some quite interesting looking shapes. We can make them look a little bit more interesting by adding some forces into the mix. Let's add a vortex, for example. Let's have a look and see what the particles do under the influence of the vortex. Well, you can't see very well, but let's make the particles bigger. So let's bake that and see what kind of shape we get. So we bake the simulation, and then dynamics, convert particle cache, particles to curves, and we get a whole new set of curves. It's a mad anemone. Okay, so curves are pieces of geometry, so we can attach normal materials to them. So let's do that. If I type M and apply material to the curves, then that material is now attached to that curve. And we can spice things up by adding a texture, for example. So one of the random textures, I'll choose marble noise. By default this comes up on the solid setting, which is just what we need. If I just adjust the size appropriately, we can get some interesting texture on the tubes. Change the colours. Okay, we're nearly done, finally. The last thing I want to show you is texture replicators. Texture replicators are used to distribute a texture across a surface. The way they work is that small patches of texture are applied to the surface in the position of particles. So you can see where this is going. We can create particles and move them close to a surface, and then any texture replicator that's associated with that particle source will be applied to the surface. The first thing I need to do is bake the simulation. So now the simulation is baked, I can scrub the timeline to see what's going on. So you can see we have a number of particles which are drawn using our replicator. So this ball is drawn at the position of each of the particles, but we also have a texture replicator, and the texture replicator is placing this transparency texture at the position of each particle. When the particles move away from the surface, then we don't get the replicated texture. It's only when they're close to the surface that the replica is applied. We've already seen how geometry replicators work. Let's have a look at the texture replicators. So I've deleted the texture replicator and I'll create it again from scratch to show you how it's done. First we need to add an image map, because it doesn't have to be an image map, but that's what I'm going to do in this case. And I'm going to use this image to cut out a hole in the surface. Okay, so initially the texture comes in affecting the diffuse color. We don't want that. We want it to affect the transparent amount, and it's the wrong way round. So we can deal with that by inverting. Now we've got a hole where the black is, and that's what I want. So the tricky bit is setting up the texture replicator itself. This you'll find under Texture Locator, and again if we expand this out, you'll find Texture Replicator at the bottom. We need to specify a particle source. In this case it will be the particle simulation, and we need to adjust the size, bias and gain to get the effect that we're after. So I happen to know that for this example I need a particle size of 3 or thereabouts, and I'll set my bias to 0 and my gain to 100, and then everywhere that a particle gets close to the surface, the texture replicator creates a hole. I've seen this used to good effect to create cracks on the surface when particles collide with them. So basically you would clone the particle when it hits the surface and just leave it sitting there, generating the crack texture. You can also see the texture locator in the schematic view, and I've noticed something that happens occasionally with texture replicators, in that the particle source in here gets greyed out and can't be used anymore. If that happens to you, then you can still connect up the particle source in the schematic view. Okay, that's it for rendering. I hope you enjoyed this video. You have my congratulations for making it to the end, and I'll see you next time in what I hope will be some shorter videos on specific features of the particle system.